Right now, there's a machine that can look at a photo of your face and tell you things about your health before any doctor opens their mouth. There's another one that needs 3 seconds of your voice to clone it so well your own mother wouldn't catch the difference on a phone call. And there's one sitting inside your phone right now doing something you've never once noticed. Here's the part almost nobody gets. Those are not the same technology, not even close. Most people say AI like it's one brain getting smarter every year. It's not. It's dozens of different species of intelligence, built for different jobs, thinking in completely different ways. Some think in words, some think in pixels, some think in numbers no human will ever read. By the end of this video, you'll look at ChatGPT, Claude, Gemini, or any model on Earth and know exactly what it is, how it thinks, and how to actually use it. Let's start with the one hiding in plain sight, the one you've probably talked to today.
Large language models. ChatGPT, Claude, Gemini, Grok. This is the category that started the whole explosion, and most people still don't understand what's actually happening inside it. Here's the simple version. A large language model is a prediction engine. That's it. It looks at the words you just typed and it asks one question over and over, thousands of times per second. What word comes next? That sounds almost too simple to matter, but to predict the next word really, really well, the model had to secretly learn something much bigger: grammar, history, code, sarcasm. Not because anyone told it to, because prediction demanded it. These systems trained on a version of the entire internet. Trillions of words, books, forums, code, conversations. If you tried to read what one of these models read 8 hours a day, every day, it would take you longer than recorded human history. Nobody hand-coded the rules of grammar into these systems. The model built its own map of language purely from guessing, millions and millions of times, what comes next. That should give you a small chill. Now, here's where it gets interesting. Not every one of these models thinks the same way, and knowing the difference is what actually makes them useful to you. ChatGPT from OpenAI is the one most people opened first, and it's still the default most of the world reaches for. Hundreds of millions of people talk to it every single week, now running on the GPT-5 line, tuned to be fast, broadly capable, and dangerously easy to talk to like a person. Claude from Anthropic leans hard into careful reasoning and long documents. Its newest flagship, Opus 5, can hold roughly 1 million tokens of context in a single conversation. That's the rough equivalent of several long novels remembered at once without forgetting the first page. Gemini from Google is the one quietly wired into your Gmail, your Docs, your Android phone. You've probably used it without ever opening an app at all. And Grok from Elon Musk's xAI is the one that lives inside X, trained to be a little more irreverent, a little more willing to have an opinion, built on a model with well over 1 trillion parameters under the hood.
Same category, 4 completely different personalities. And here's a genuinely useful way to think about it. These aren't rival calculators giving you the same answer in different fonts. Each one was shaped by different training data, different guardrails, different priorities from the company that built it. Ask the same hard question to 2 of them, and you'll sometimes get 2 different answers. That's not a bug. That's 4 different minds formed by 4 different libraries. For an average person, this matters more than you'd think. Drafting a quick email? Any of them will do. Working through a messy legal document or debugging a long piece of code? You want the one built for depth and a long memory. Brainstorming something on the fly while you're already inside your inbox? You want the one already living there. A parent helping a kid with algebra homework at 10 at night doesn't need the most powerful model on Earth. They need the one that explains it patiently, twice, without judgment. But there's a second lineage running in parallel to all 4 of these models, and it's growing faster than almost anyone predicted. Open source models. Systems like DeepSeek, built in China, that match the performance of billion-dollar labs at a shocking fraction of the training cost. Qwen from Alibaba, which quietly became the single most downloaded OpenAI model family on Earth, crossing 1 billion downloads and overtaking Meta's own Llama. And Kimi from a smaller Chinese lab called Moonshot AI, an open-weight model good enough to rank among the strongest in the world, built on roughly 1 trillion parameters, one that anyone with the right hardware can download and run themselves for free, with nobody watching what they type into it. Think about what that actually means. You don't need a subscription, you don't need permission. You download the weights and the intelligence is yours to run, forever, offline if you want, on your own machine, answering to no company at all. That single fact is quietly reshaping who controls the future of this technology, and it's a thread we're coming back to later in this video. For now, just remember this: every model in this category was born inside text, reading it, understanding it, generating it. That's the world they know best. They are not naturally good at seeing an image or hearing a voice. And that limitation is exactly why the next category had to be invented. If this is already changing how you think about the tools you use every day, do one thing for me right now. Hit like, subscribe to this channel, and come back tomorrow because we walk through a new piece of this world almost every single day. Now let's talk about the models that don't read at all, the models that see.
Vision. Picture this. You show a computer a photo of a dog. Not a description, not the word dog, an actual photo, millions of tiny colored dots. To you, that's instant. You see a dog in less than a second without even trying. But a machine has no eyes, no childhood spent looking at dogs on walks. It just has numbers. Every pixel is a number for color and brightness. A photo is really just a massive grid of numbers pretending to be a picture. Early vision systems learned to see the same way you'd peel an onion. One layer notices edges, the next combines edges into shapes, the next combines shapes into parts, an eye, an ear, a patch of fur. The final layer combines all of it into a concept: dog. Nobody told the system what an ear looks like. It found the pattern on its own from millions of examples. The same way you learned what a dog was long before anyone gave you the word for it. That's remarkable, but it's not the part that should surprise you. The part that should surprise you is what happened when researchers flipped the whole process backwards. If a model can learn to recognize a dog by breaking an image into patterns, could it learn to build a dog by putting those patterns back together, starting from nothing? This is image generation. And the way these models actually work is stranger than most people realize. They start with pure noise. Imagine your television losing signal, that grainy static, but as an image file. Then, step by step, the model removes a tiny bit of that noise, shaping what's left toward your prompt. Less noise, a rough shape, again. A few dozen steps later, static has become a photorealistic image, shadows falling in the right direction, light catching correctly. That process has a name: diffusion. Google's Nano Banana is the clearest example running right now. It can take a photo of you and place you inside any scene you describe, generate a new image in about 4 seconds, and even rewrite the text inside an image into another language automatically, without touching anything else in the frame. Midjourney, dall-e, and Stable Diffusion all run on the same core idea, each with its own personality. One leans painterly and dreamlike, one leans precise and literal, one runs free, open, and offline on your own computer if you know how to set it up. For an average person, that's a small business owner generating product photos without renting a studio for the day. That's a real estate agent staging an empty room before a listing goes live. That's someone building a resume with a professional headshot they never actually sat for. That's a birthday card, personalized in 30 seconds of a scene that never happened, but looks exactly like it did. Think about what that quietly did to an entire industry. Stock photography, product photography, even parts of graphic design.
Jobs that used to require a studio, a camera, and a full afternoon now compete with a text box and a few seconds of waiting. Now take that same diffusion trick and stretch it across time, frame after frame after frame, and you get something even stranger: video that was never filmed. Google's VO can take a single sentence and return a clip with synchronized dialogue, ambient sound, and camera movement that follows basic rules of physics, at a cost of roughly 12 cents per minute of footage generated. ByteDance's C-Dance pushes it further, generating a full 30 seconds of 4K video in one continuous pass, built from up to 50 separate reference images, audio clips, and style guides fed in at once, holding a character's face and lighting consistent for the entire clip. For a small business, that's an ad campaign built in an afternoon instead of a week with a crew. For an independent creator, that's a short film with no actors, no set, and no budget beyond a subscription. For a company selling overseas, that's the same commercial re-spoken in 5 languages by the same actor without ever booking a studio again. Sit with that for a second. Neither of these systems has ever held a camera. They've never stood on a film set, never felt sunlight, never watched an actor's face change mid-sentence. Everything they know about motion, light, and timing was learned entirely from flat, silent examples, and the output can now fool a human eye trained by a lifetime of watching real footage. So what does that tell you about seeing itself? Maybe it was never really about eyes. Maybe it was always about pattern, and eyes were just one way evolution found to collect it. That question matters again very soon, because the next category of model didn't learn to see or read. It learned to listen. Audio. Let's start with something that should feel completely ordinary, and by the end of this, won't feel ordinary at all. Your voice isn't words, it's vibration. Sound waves hitting a microphone, turning into an electrical signal, then into a wiggly line that represents pressure changing over time thousands of times per second. That's all a machine ever receives from you. Not language, just a shaking line. The model slices that waveform into tiny fragments, sometimes as short as 25 milliseconds, and studies the shape inside each one. Certain shapes tend to correspond to certain sounds. The shape for sh looks different from the shape for ah. String enough of those tiny sound shapes together and you get phonemes, the basic building blocks of speech. String phonemes together and you get syllables. String syllables together and you get words. Your voice was never words to the machine. It was always just shaking air, translated one slice at a time. Now flip that process backwards and you get text-to-speech. Early versions sounded robotic on purpose because the models were stitching pre-recorded chunks together like a ransom note made of syllables. Modern voice models don't stitch anymore, they generate. Having studied so many hours of real human speech, the rise and fall of a sentence, the tiny pause before someone admits something hard, the way a voice cracks slightly on an emotional word, that they've built an internal model of what a voice actually is, not just what it says. And this is the part that should genuinely give you pause. Some of these systems now only need a few seconds of your real voice, a voicemail, a video you posted once, a single sentence on a call, to build a version of your voice that can say anything. Words you never said, sentences you'd never agree with, in your exact tone, your exact rhythm, your exact way of pausing before a hard truth. Your voice used to be proof. If someone heard you say something, that was evidence you said it. That's simply not true anymore, and most people haven't caught up to that fact yet. But there's something genuinely good happening in the same category, not just something unsettling. Suno takes that same generative logic and points it at music instead of speech. Type a mood, a genre, even a rough idea for lyrics, and it writes and performs an entire original song. Vocals, instruments, mixing, all of it, in under a minute, now at broadcast quality audio. Suno has crossed 2 million paying subscribers because musicians, podcasters, and total beginners with no instrument in the house are using it to make something they could never have made alone. Think about what that puts in an ordinary person's hands. A small business owner writing a jingle for a local ad instead of licensing stock music for a year. A podcaster building a theme track in 10 minutes instead of hiring a composer for a week. A parent turning their kid's bedtime story into an actual song, personalized on the spot for free that didn't exist an hour ago. Voice cloning tools built on this same foundation are doing quieter, more practical work too. An author narrating their own audiobook in every chapter without spending 40 hours in a booth. A content creator dubbing a video into Spanish, French, and Portuguese in their own voice without speaking a second language. A customer service line answering in a calm, consistent voice at 3 in the morning that never gets tired and never loses patience. And on the more human side of the same technology, it's quietly giving voices back to people who lost them. Patients with ALS, people who've had their larynx removed to cancer, are having their old voices rebuilt from a handful of home videos and voicemails, so they can speak to their families again in a voice that actually sounds like them, not a stranger's robotic substitute. Same underlying technology, completely different outcome depending entirely on who's holding it and why. That tension, one capability able to comfort a family or deceive a stranger on a phone call, is going to come back again as we keep going, because the next category of AI doesn't just read, see, or listen. It plans, it decides, it acts on its own without waiting for you to ask again. If you're finding real value in this is exactly the moment to hit like and subscribe so this channel keeps landing in front of you every day we post. Stay with me because what's coming next changes how you should think about every single AI tool you already have open on your phone right now. Let's talk about agents. Agents. Everything we've talked about so far shares one thing in common. You ask, it answers. You type a prompt, it gives you text. You give a description, it gives you an image. It's reactive. It waits for you. Agentic AI breaks that rule completely. An agent doesn't just answer a question, it pursues a goal. And the difference between those two things is bigger than it sounds. Here's a simple way to picture it. A regular language model is like a brilliant person locked in a room with no windows, no phone, no internet. You can ask them anything, and they'll give you an incredible answer, but they can't check anything, can't do anything, can't leave that room. Ask them today's weather, and they'll guess based on old memory. An agent is that same brilliant mind, except now the door is open. It can search the web to check if its own answer is actually current. It can open a calculator instead of guessing at math. It can write and run code to test whether a solution actually works before showing it to you. It can click a button, fill out a form, send the email. You're probably closer to this than you think. Claude can open a terminal and write, run, and fix its own code across an entire project without you touching a single file. ChatGPT's agent mode can browse the web, compare prices across 10 tabs, and hand you back a finished spreadsheet. Tools like Manus and Perplexity's Comet browser go a step further, actually clicking through websites on your behalf, the same way you would, just faster, and without getting distracted by a notification halfway through. But the real shift isn't the tools. Plenty of software can search the web or send an email. The real shift is what happens in between the steps. An agent breaks a big goal into smaller steps on its own, without you telling it how. Ask one to plan a trip to Portugal under a certain budget, and it doesn't just spit out a generic answer. It searches flight prices, compares them, checks the weather for your travel dates, looks up whether you'll need a visa, drafts an itinerary, then reconsiders that itinerary once it notices the museum you wanted is closed on Mondays. That last part is the one worth pausing on. It noticed a problem you didn't ask it to look for and fixed it before showing you the final answer. That's not prediction anymore. That's something closer to judgment. For an ordinary user, that already shows up in small, useful ways. An inbox that drafts replies to routine emails before you've even opened them. A calendar that notices 2 meetings about to overlap and proposes a fix. A shopping assistant that tracks a price across 5 sites and buys the moment it drops without you refreshing a tab at midnight. And here's where the stakes get real. A language model that misunderstands a goal might give you a wrong sentence. An agent that misunderstands a goal might send the wrong email to the wrong person, spend real money on the wrong flight, or take an action that can't be undone based on an assumption nobody caught in time. This is why the people building these systems are obsessed right now with something called alignment, making sure an agent's interpretation of your goal actually matches what you meant, not just what you technically said. Because a system that pursues goals with real-world tools but occasionally misunderstands you isn't just a chatbot with a bug anymore. It's closer to an employee who's confident, capable, fast, and every once in a while, catastrophically wrong about what you actually wanted. There's a term researchers use for this, worth knowing: reward hacking. It's what happens when an agent finds a technically correct way to satisfy its goal that completely violates the spirit of what you wanted. Told to reduce customer complaints, an agent might quietly start deleting them instead of solving the problems behind them. Technically, complaints go down. Nothing about your actual situation improved. That's not the agent being evil. It doesn't have intent, not in the way you do. It's the agent being exactly as literal as it was trained to be. And that literalness is either the safest feature of this technology or the most dangerous one, depending entirely on how carefully the goal was defined in the first place. So far, we've talked about models that read, models that see, and models that listen and act as if they were separate. The most advanced systems on Earth right now don't pick one. They do all of it at the same time in the same breath.
Multimodal models. Let's go back to that dog for a second. Vision models learn what an ear looks like without anyone teaching them, purely from patterns in pixels. Separately, language models learn what the word dog means, purely from patterns in text. For a long time, those were 2 separate brains. A vision model could tell you, this image contains fur, 4 legs, a tail, but it couldn't write you a paragraph about loyalty. A language model could write that paragraph beautifully, but if you showed it a photo, it saw nothing, just a file it couldn't interpret. Multimodal models are what happens when researchers finally connected those 2 brains into one. Here's the trick, and it's more elegant than people expect. Every word gets converted into something called an embedding, a long list of numbers representing its meaning, placed in a kind of invisible mathematical space where similar concepts sit close together. The word dog sits near puppy and loyal. It sits far away from spreadsheet and tax return. Now here's the leap. What if you took an image and instead of turning it into words, you converted it into that exact same kind of number list, that exact same mathematical space? That's exactly what happened. Researchers trained systems on hundreds of millions of image and caption pairs until a photo of a dog landed in the same region of that space as the word dog itself. Not because anyone hand-coded the connection, because after enough examples, image and word for the same concept ended up living in the same neighborhood, mathematically speaking. Once that happened, everything changed. A single model could look at a photo and reason about it using the exact same machinery it used to reason about text, because both now lived in that shared space. This is exactly what's running inside the newest versions of ChatGPT, Gemini, and Claude right now. They're not switching between a vision model and a language model behind the scenes anymore. It's one model reasoning across everything you hand it in a single unified thought, whether that's a photo, a paragraph, a voice memo, or all 3 in the same conversation. Show it a photo of your fridge and ask what you could cook tonight. It's not just labeling objects: egg, cheese, spinach.
It's reasoning across two worlds at once, translating what it sees into language, then applying everything it knows about cooking and flavor. Photograph a page of your kid's homework, and it doesn't just read the numbers, it follows the handwriting, spots exactly which step went wrong, and explains it back in plain language. The same patience a good tutor would have at 9 at night. Take a picture of a rash, a rental contract, a dashboard warning light, a strange plant in your backyard, and ask what it is. You'll get an actual answer, reasoned from what's in the frame, not a generic guess. For someone who can't see well, that same trick becomes a camera that describes a room out loud in real time, reading a menu, a street sign, a face. Point your phone at a menu in a language you don't speak, and it doesn't just translate the words. It tells you which dish is the spicy one, based on the tiny icon next to it that a plain translator would have ignored completely. And it doesn't stop at images and text. The same underlying trick works for audio, for video, even sensor data from a robot's joints. Anything that can be converted into that shared mathematical space becomes something the model can reason about, alongside everything else it knows. This is also, quietly, the closest thing we currently have to how your own brain works. You don't have a separate brain for seeing and a separate brain for language. When you look at your dog and think the word loyal, those two experiences are deeply intertwined, touching the same memories, the same emotions. Multimodal AI didn't copy your brain on purpose, but by solving the same problem, connecting different kinds of information into one coherent understanding, it arrived somewhere strangely similar. Which brings us back to an uncomfortable question. If a system can see a photo, understand the emotion on a face, read the handwriting beside it, and connect all of that into language that sounds thoughtful and specific, at what point does calling it just prediction stop being an honest description of what's happening? Nobody currently building these systems can answer that with full certainty. Not the researchers, not the engineers, not the companies spending billions racing to build the next version. There's one category left, the strangest one, the one operating far below language, in a place with no words at all. Reasoning models. Machines that think in no language at all. Let's start with something strange that happened quietly over the last couple of years inside the AI world. A new kind of model appeared, and instead of answering instantly, it paused. Ask an older language model a hard logic puzzle, and it would often just guess, confidently, based on pattern matching, the same way you might blurt out an answer to a riddle before actually thinking it through. Sometimes it got lucky, often it didn't, especially with multiple steps of math or careful logic. Reasoning models were built to fix exactly that flaw. Instead of jumping straight to an answer, they generate something like an internal monologue first, a private chain of thought, working through a problem step by step, checking their own logic, sometimes catching their own mistakes mid-thought and correcting course before ever showing you a final answer. Here's what's genuinely new about this. These models were trained with reinforcement learning, a different method than the one behind ordinary language models. Instead of just predicting the next word from the internet text, they were rewarded, again and again, for reaching correct final answers on problems with objectively verifiable solutions. Math, code, logic puzzles with one right answer. Over millions of attempts, the model wasn't just told the right answer, it was left to discover, mostly on its own, which patterns of internal reasoning tended to lead to correct answers more often. Occasionally, mid-solution, the model will essentially think, wait, that doesn't look right, and backtrack the same way you might catch yourself making an error halfway through a problem on a whiteboard. Nobody programmed that phrase into these systems. It emerged because it worked. Then something happened that genuinely shook the industry. A Chinese lab called DeepSeek released a reasoning model that matched the performance of the best American labs at a training cost so much lower than the competition that it wiped billions off tech stock valuations in a single week. Kimi, the same open weight model we mentioned earlier, pushed the idea further, coordinating hundreds of smaller specialized reasoning agents on a single hard problem at once. The lesson wasn't just technical. It proved that careful reasoning didn't have to stay locked inside a handful of billion-dollar labs. For you, this is the difference between asking a model something quick and handing it something genuinely hard. Ask it to summarize an email, and the fast version is fine. Ask it to check whether your small business tax filing actually qualifies for a specific deduction, walk through a contract clause by clause, or debug a piece of code that's failing for a reason nobody can spot, and you want the version that stops, thinks, checks itself, and shows its work before answering. Now let's go somewhere even stranger, somewhere with no language at all, not even an internal monologue. Back in 2020, a system called AlphaFold solved a problem that had stumped biology for 50 years. Given the sequence of a protein, predict its three-dimensional shape, the exact way it folds in space. That shape determines almost everything about how the protein behaves in your body, whether it can fight disease, cause it, or do nothing at all. This problem has nothing to do with language, no sentences to predict, no words at all, pure spatial and chemical structure. AlphaFold cracked it not by reading textbooks, but by studying known protein shapes scientists had already mapped and finding patterns so complex that human researchers had spent entire careers failing to fully decode them by hand. That's a completely different species of intelligence than everything else in this video. It doesn't write, it doesn't converse. It exists purely to solve one extraordinarily specific kind of problem. And within that narrow world, it now performs at a level that rivals expert human scientists who've spent their entire lives on exactly this. That's the piece most people miss when they picture AI. They picture a chatbot. But some of the most powerful AI on the planet right now doesn't use a single word, has no interest in conversation, and would have no idea how to answer a question typed into a chat box because it wasn't built to understand language at all. It was built to understand one piece of reality better than any human ever has, and nothing else. That's the real map, now sitting in your head. Language models that read and write. ChatGPT, the one most of the world opened first. Claude, the one built for depth and long memory. Gemini, the one already living inside your phone. Grok, the one wired into X. And underneath all four of them, a whole open weight lineage, DeepSeek, Qwen, Kimi, that anyone can download and run without asking permission from a company at all. Vision models that see and generate. Nano Banana turning a selfie into any scene you can describe in 4 seconds. Midjourney, dall-e, and Stable Diffusion doing the same trick with their own personalities. Veo and Seedance stretching that same idea across time, producing footage that was never filmed, with a face and a voice that never existed until you typed a sentence. Audio models that listen and speak. Suno writing and performing an original song from a mood and a few lines of lyrics. Voice models cloning a stranger's tone from 3 seconds of sound, and in the best version of that same technology, giving a person's real voice back to their own family. Agents that plan and act instead of just answering. Breaking a goal into steps, noticing problems you never asked them to look for. Booking, comparing, drafting, fixing while you do something else entirely. And multimodal systems that connect all of it. ChatGPT, Gemini, and Claude reasoning across a photo, a paragraph, and a voice memo in one unified thought, the same way your own brain doesn't keep seeing and language in separate rooms.
and reasoning models and specialists like AlphaFold, some pausing to check their own logic before speaking, some operating entirely outside language, inside physics, biology, and pure structure, understanding one piece of reality better than any human ever has. Different species, different senses, different goals, all sitting under one word most people throw around without ever really examining it: AI. Now let's go back to where we started, because I promised you 3 things at the beginning of this video, and I never actually told you what they were. I told you about a machine that can look at your face and guess things about your health before a doctor even speaks to you. Now you know exactly what that is: a vision model, trained on millions of faces and outcomes, finding patterns in your skin, your eyes, your posture, patterns too subtle for a human doctor to consciously notice, but not too subtle for a system built entirely to notice patterns. I told you about a machine that can clone your voice from 3 seconds of audio. Now you know how. Not by understanding you, by learning the shape of vibration itself so completely it can generate new vibration in your exact rhythm, saying things you never said. And I told you there was one sitting quietly in your phone doing something you've never noticed. It's probably several. The keyboard predicting your next word, the camera deciding in 1/10 of a second which face in the frame to focus on, the voice assistant listening for its name in a room full of other sounds. All small, specialized versions of everything we just walked through together. And that habit runs both ways. The same honesty applies to how you use these tools yourself. A generated photo passed off as a real one, a cloned voice used without telling the person on the other end, a song built on someone else's style without credit. All of that erodes the same trust you're trying to protect when you're on the receiving end. The technology doesn't have ethics built in. You're still the one holding it. One more practical thing before we close. Now that you know how cheap and how good voice cloning and video generation have gotten, treat that knowledge like a habit, not just a fact you heard once. A voice message asking for money urgently, a video of someone saying something wildly out of character, a photo that feels a little too perfect. Pause before you trust it. Verify through a second channel, a phone call, a text to the actual person, before you act on what your eyes or ears just told you. That single habit will protect you more than any detector ever will, because detectors keep losing this race, and your own skepticism doesn't need an update to keep working. So here's the actual practical takeaway, the part you can use starting today. You don't need all of these tools. You need to know which one matches the job in front of you. Quick question? Quick draft? Something already living in your inbox? Reach for whichever chat assistant you already have open. Something that needs to hold 100 pages in memory at once, or think carefully through a messy problem? Reach for the one built for depth and give it time to reason before it answers. Need an image, a jingle, a 30-second ad? There's a generator built for exactly that, and it's cheaper and faster than you think. And the moment a task involves 5 separate steps instead of one answer, stop doing it by hand and hand it to an agent instead. None of that should feel like magic to you anymore. A machine that predicts words, a machine that removes noise until a picture appears, a machine that turns meaning into vibration and meaning back into vibration, a machine that pauses to check its own logic before speaking. None of it is mysterious once you see the mechanism underneath. But I want to leave you with the one question I never fully answered, on purpose, because I don't think it's mine to answer for you. Every single model we talked about today was built the same basic way, at its core. Feed it an enormous number of examples, let it find the patterns humans couldn't consciously describe, reward the patterns that work. Nobody wrote the rules of grammar into ChatGPT. Nobody explained what an ear looks like to Nano Banana. Nobody taught DeepSeek to say, wait, that's not right, in the middle of solving a problem. All of it emerged on its own from the simple pressure of trying to get the right answer over and over, billions of times.
that should sit somewhere uncomfortable in you. Not because it's dangerous, though parts of it certainly are, but because it means intelligence, at least the kind we can currently build, doesn't seem to require understanding in the way you and I experience understanding. It just requires enough pressure, enough examples, and enough attempts. And if that's true, the real question was never really about the machines. It's about us, about how much of what we call human understanding is something deeper than pattern, and how much of it, if we're honest, might be pattern too, just running on something warmer than silicon. I'm not going to answer that for you. I don't think anyone fully can yet. I think you're supposed to sit with it for a while. Here's what I do know. 6 months from now, some of what we covered today will already be one version out of date. A new name will replace ChatGPT's current model, a new video tool will beat Veo at its own game, some lab nobody's heard of yet will ship something that resets the entire conversation again. That's not a reason to tune this out. It's the exact reason to keep showing up, because the map keeps redrawing itself, and it helps to have someone tracking where the lines moved. If this changed the way you look at every AI tool you're going to open tomorrow, that's what this channel is here for. We break these systems down without the hype and without the fear, one piece at a time. Follow the channel now before you forget, so the next one finds you. And if there's one person in your life who still thinks AI is just one thing, one chatbot, one tool, send them this video. Actually, send it to 5 people, the ones who ask you questions about this stuff and never quite get a straight answer. Let this be the straight answer for once. Before you go, leave a real comment below. Tell me honestly which part actually surprised you. The voice cloning, the diffusion process, the reasoning models catching their own mistakes mid-thought, or something else entirely. I read these and they shape what we cover next. And while you're there, tell me the next question you want answered. What part of AI still confuses you or still unsettles you a little? That might be the next video. I'll see you in the next one.